many of its mysteries. And now, in another mind-boggling discovery, the James Webb has managed to discover the primordial galaxies, as old as the age of our universe. Yes, you have heard it right. In the deep field image, James Webb's vision finds a large number of impossible early galaxies that date back several 100 million years after the Big Bang. Out of nowhere, galaxies began to reveal themselves by emerging from the darkness of space and time. For the first time, the universe started to seem far stranger than we had previously imagined. Revelation of the oldest galaxies in the universe. A twist, though, came this year when some massive galaxies discovered, which are thought to be around 300 million years old after the Big Bang, raised questions about the widely accepted cosmological model. The James Webb observations of these galaxies exceeded previous size predictions. This is one of the most interesting and confounding discoveries made by the James Webb Space Telescope. About 300 to 400 galaxies in the universe is thought to be one of the many cosmic riddles that can be solved by studying this era. However, once Webb acquired pictures of these early galaxies, scientists discovered an unexpected finding. The galaxies were far bigger than predicted by the most widely used cosmological model. Astronomers and astrophysicists have been trying to figure out how these galaxies could have formed ever since. These galaxies formed during a crucial period known as the Epoch of Reionization, which occurred 300 to 500 million years after the Big Bang, or more than 13 billion years ago, when the universe was only 2% of its current age. This epoch followed a period dubbed the Cosmic Dark Ages, marking the dawn of stars becoming visible to the naked eye. One of them is Jade's GSZ 13-0, with a redshift of 13.2, meaning we are seeing the galaxy as it appeared just 320 million years after the Big Bang. The reason astronomers are so excited about Jade's GSZ 13-0 is because its high redshift makes it one of the universe's most distant known galaxies, a record that JWST seems likely to break again soon. However, not all high redshift candidate galaxies have been so lucky, which emphasizes the early caution of astronomers. Just 240 million years after the Big Bang in July 2023, Finkelstein's Cosmic Evolution Early Release Science Study, another study, detected a potential galaxy with a redshift of 16.4. Among these is Maisie's galaxy, named for Finkelstein's daughter because it was discovered on her birthday. It can be observed at a redshift of 11.4, or roughly 390 million years after the Big Bang. Redshift of faraway galaxies. There is no timestamp on anything made in outer space. Astronomers measure an object's redshift to determine when the light it emits left it. In the visible spectrum, short wavelength, high-frequency light is blue, whereas long wavelength, low-frequency light is red. This is because different wavelengths of light have distinct color properties. The expansion of the cosmos causes the distant source, such as an early galaxy, to concurrently move away from us, while light from that source travels across the cosmos to reach us. The light wavelengths the source is emitting then become stretched out as a result, losing energy and changing frequency. The light is effectively being shifted towards the red end of the electromagnetic spectrum, hence the term redshift used by astronomers to describe this alteration. That light can eventually straddle the infrared spectrum. Infrared light is invisible to human vision. The more extreme the redshift, the further cosmic light has traveled. With the confirmation of these galaxies, the scientific implications can now be investigated in more detail. Compared to the Milky Way, these galaxies are much smaller. However, a few look incredibly huge and bright, with star formation rates as high as our galaxies, which produces about one new star annually. The main question here is how these galaxies were able to release so much energy into space. Rise of these massive galaxies is way faster than previously thought by astronomers. The ground and the neutral hydrogen clouds that surrounded the universe were the only sources of photons. As galaxies began to form, the neutral hydrogen started to reionize due to the radiation from their hot, massive stars, which were 1,000 times more massive than our Sun. Many massive galaxies that formed only 500 million years after the Big Bang have been discovered by astronomers, pushing the boundaries of what is observable thanks to Webb's exceptional sensitivity to infrared light. According to the LCDM model, there simply wasn't enough time since the Big Bang for so many galaxies to have formed and become so massive. According to accepted theories of galaxy formation, the hydrogen that permeated the early universe compressed into massive spherical clouds of dark matter, where it gathered to form the first star population. Astronomers are especially interested in the primordial supermassive black holes, which occurred approximately 1 billion years after the Big Bang and had a mass 1,000 times that of the Sun. Once again, what it is. Instead, it might be a staggering 26.7 billion years old. Rajendra Gupta, an adjunct physics professor at the University of Ottawa, strongly disagrees with the current cosmological model by claiming that the universe is actually 26.7 billion years old based on deep space observations from the James Webb Space Telescope. It resolves the mystery surrounding the impossible early galaxy problem and drastically changes our understanding of the cosmos. Astronomers and physicists have traditionally determined the universe's age by measuring the time since the Big Bang and studying the oldest stars based on redshift observations. But the finding of early galaxies with advanced evolutionary characteristics and the existence of stars like Methuselah, which seem older than the universe's estimated age, have baffled scientists. Observed merely 300 million years after the Big Bang, these early galaxies show masses and maturities typical of billions of years of cosmic evolution, creating a major puzzle. In response to these challenges, Gupta presents Zwicky's tired light theory, which suggests that photons gradually losing energy over enormous cosmic distances is what causes the redshift of light from far-off galaxies. Gupta proposes a hybrid interpretation of redshift that more fully explains the findings, by allowing this hypothesis to coexist with the expanding cosmos. Gupta also takes into account the idea of evolving coupling constants, which are fundamental physical constants influencing particle interactions and were theorized by Paul Dirac. By allowing these constants to vary over time, the formation time frame for early galaxies observed by the James Webb Space Telescope can be extended from a few hundred million to several billion years. This offers a possible explanation for the advanced mass and development seen in these old galaxies. Gupta proposes that the traditional interpretation of the cosmological constant responsible for the universe's accelerating expansion needs revision, which represents dark energy responsible for the accelerating expansion of the universe. Indeed, after the hectic first few weeks of James Webb But if there's one thing the telescope is teaching us, it's to always expect and inspiring future generations to delve even deeper into the mysteries of space. I hope you enjoyed this video. Don't forget to hit the like button and subscribe to our channel for more interesting space-related content. Thank you very much for watching, and I will see you in the next video.